So we're going to look at a number of different ways of doing subtraction. But before we go on, you might ask the question of, well, why do we need to know so many ways? Isn't the standard algorithm good enough? And this has to do with something called adaptive expertise. And the basic idea behind adaptive expertise is this. If you know a number of ways of solving a given type of problem, choosing the most efficient is known as adaptive expertise. And many educational studies have shown that students who have adaptive expertise routinely outperform students who do not have adaptive expertise. So clearly, adaptive expertise is something that you want to have, you want your students to have. Well, this might seem to be yet another thing we have to worry about, but it turns out that acquiring adaptive expertise is mostly a matter of learning more than one way to solve a problem. In other words, adaptive expertise is not something that you learn in addition to multiple methods of solving a problem, but rather it's something that you learn as you are learning multiple methods of solving a problem. Now, popular culture understands, at least intuitively, that adaptive expertise is important, and this is evident in sayings like the following: if the only tool that you have is a hammer, then you treat every problem like a nail. If you only know one way to solve a problem, you have to solve the problem in that one way, even if it's not the best way of approaching the problem. So let's take a look at a method of subtraction, and this method is called counting down. And we've looked at counting up, and the difference between counting down and counting up. Consider the subtraction b minus c. Now, if I'm going to count up, I'm going to count up from c up to b, and I'm going to keep track of how far I've had to go. In contrast, in counting down, I count backwards, c units from b, and I record where I end. And again, with the idea of adaptive expertise in mind, one of these approaches will be more efficient than the other. Which one? Well, it depends. Given identical problems, the algorithm that is more efficient depends on the student. And for that matter, the same student working the same problem on a different day may decide that a different method is more efficient. There are so many factors that go into deciding which algorithm is more efficient than another that there is no general rule. With that in mind, let's consider a problem. For example, 31 minus 7. Now, in this particular case, if I try to solve this using counting up, I'd need to go from 7 up to 31, and this would take a little bit of time, especially if I count by ones, if I don't have any more efficient way of doing that. So maybe I don't want to use counting up on this problem. On the other hand, if I use counting down, I want to count the 7th number before 31, and that seems to be something that we can accomplish much faster. So let's go ahead and try it. And we might represent our task the following way. So I'm going to start at 31, and I'm going to count backwards. 30, 29, 28, 27, 26, 25, 24, and that's my 7th number backwards. So counting back 7 from 31 takes us to 24, and I can say that 31 minus 7 is equal to 24. Now, I can also represent this subtraction using arrow notation as before. So again, I'm going to start with 31. I'm going to go back 1, 2, 3, 4, 5, 6, and 7. So 31 back 7 takes you to 24, and so as before, 31 minus 7 is equal to 24. And it's worth noting, as with counting up, we can use any knowledge that we happen to have of subtraction facts to improve the efficiency of our algorithm. For example, I might start at 31, go back 1 down to 30. Now, because I'm at a 10, it might be easier for me to go back a larger amount than by single units. For example, I might know that if I count backwards by 5, I'm going to be taken back to 25. So maybe my next step is going to be 30 down to 25. And at this point, I've gone backwards 1 and 5. I've gone backwards 6. I want to go back 7, so I'll go back 1 more, and that takes me down to 24. So again, the 7th number back from 31 is going to be 24, and there's my solution using counting down.